Now, during hydrohalogenation, what you are going to have? You will always have an alkene. You will always have an alkene, which is a double bond compound. You will add a hydrogen halide. Now, hydrogen halides have the formula of H, X, in which X are halogens. And halogens, you learn that they are group 17 in the periodic table. For example, we have fluorine, we have bromine, we have iodine, we have chlorine. Those are the halogens. All right? And as a result, in the product, you will have a haloalkane. Okay? It's very, very simple. Let's see one example of hydrohalogenation. A simple example. Okay? Let's look at the simple example of hydrohalogenation, and let's begin with the simplest alkene. Okay, we are not going to obviously have all the possible options, but the simplest alkene will be ethene, isn't it? So you have two carbons, it's double bond. This will be hydrogen and hydrogen, hydrogen and hydrogen. That is ethene. It's an alkene. You always have as part of the reactant an alkene. That will be the organic reactant. Okay? Then we are going to add any hydrogen halide. Any one. So let's start with hydrogen chloride. HCl. Alright? Now what is going to happen? The double bond is going to break. It will break and you will have a space for hydrogen as well as a space for halogen. So you will have, now this is what you have before, hydrogen, 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 hydrogen. The double bond breaks and they open two spaces. Is that correct? One space will be taken by the hydrogen and the other will be taken by the chlorine. So in this case, you start with ethene and you end with chloroethane. Now, important something. The F stay constant. So the number of carbons stay constant. You cannot change the number of carbons. The only change is that now we're converting this alkene into a haloalkane. Now, things may become tricky when you have an alkene with more than 3-4 carbons involved. When you have substituents, etc., etc. Okay? Because there are some rules we have to look. So let's look at another example. And another example, and let's make it, for instance, propene. From propene to something else. So in this example, we're going to have 1, 2, and 3 carbons. All right? Hydrogen, hydrogen, 1 hydrogen. And we are going to add exactly the same hydrohalogen. It doesn't really matter which one because it's the same application. The only difference is the halogen changes. So we're going to add hydrogen chloride. All right. So now when this happens, there are certain conditions. We'll speak about those eventually. But when this happens, you have two possibilities. So two different products can form. The first product that can form is when you come here. Let me just write it down. 1, 2, 3. The double bond breaks there. Is that correct? It was double. Now it's going to have single bond. Maybe I can even change the color so you can see. There was the double bond. Okay? So what we had, this one is the product. This is hydrogen, 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 and hydrogen. So now we have two spaces. One here and one there. So I'm going to repeat that one because we have two possibilities. Now what will the difference be? In one of them, the hydrogen will come to the first carbon and the Cl will come to the second carbon. The other option could be that the Cl come to the first carbon and the hydrogen come to the second carbon. Okay? There you can see it. Those are the two options. Now, when this happens, we have to go to a rule called Markovnikov rule. What does Markovnikov say? The hydrogen will go most of the time to the carbon that has more hydrogen. I said most of the time. So most of the time, the hydrogen is going to go to the carbon that has more hydrogen. So in other words, you'll have one of the two that will be formed more. Both of them will form during this chemical reaction, but one of them will form more than the other, because hydrogen most of the time go to form or to go to a carbon that have more hydrogen. Like hydrogen like to be with friends. All right, so we call this first one here major product, which means it's the product that is going to be formed more. That is the major product, because this hydrogen came to the carbon that has more hydrogen. That carbon has before two hydrogen, as you can see there. The other carbon have only one hydrogen. So the hydrogen, to form the major product, the hydrogen will go to the carbon that has more hydrogen. Guys, it's simple. So you look at the two possibilities. That's why I did repeat. There are two possibilities. Hydrogen will go to the carbon that has more hydrogen. All right, that is the major product. And the other product is the minor. So which one is going to form more? The first one, which is the major product. This one will form most of the time. So now, during the test, you are always going to use the major product. Always. Except if they specify. At least they say give the minor product, you always going to go to the major product. Always. And it's simple. The hydrogen will go all the time to the carbon that has more hydrogen. Okay, maybe let's look at another example here so you get the idea of the minor and major product. There we go. And then in this chemical reaction, we are going to add, that is not for adding. We're going to add hydrogen bromide this time. Okay? So that is the reaction. This is 2-methyl. It's a little bit tricky because you have a double bond right in the center. So then you have to go to substituent. That is why when you start counting, you start from here. 1, 2, 3, and 4. Can you see that? So it's 2-methyl, but 2 in. The double bond is in carbon number 2 as well. So that is but 2 in. All right, so the product must also be but, for sure. You cannot change the number of carbon. So now what is going to happen? Now we have the same compound, but the double bonds break and make spaces for the hydrogen and the halogen. Okay, so let's have here the same compound, but just open spaces. There are 2 spaces for the hydrogen and the bromine. There are 2 spaces, is that correct? So using Markovnikov, which one will the major product be? Hydrogen go to the carbon that has the most number of hydrogen. Which of the 2 have more hydrogen? So this one is connected to a carbon, not to a hydrogen. So you cannot count the hydrogen that substituent has. It does not count. It's the hydrogens that are straight bonded to the carbon. So in other words, this one here have more hydrogen because it has 1 hydrogen there. This carbon is not bonded to any hydrogen. It's bonded to another carbon. So they will go the Br. You see? Yes, it's easy. So the name of this compound will be, and that is the major product. It's really simple. Okay? So that is that specific reaction. That is hydrohalogenation. So the condition here is that water cannot be present. You cannot have water in this reaction. Is that understood? So it's water-free reaction.